wonderful students. I'm glad to see you again in class. You're welcome to Eko Learners Support for WAEC and NECO candidates. Let me ask you, how is it going with your study? I believe that you're actually giving it your best. I remain your instructor, Jima Rashid, and today I'll be taking you around the fascinating world of chemistry again. Let's look at what we have for today's class.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
We would be continuing one of the topics that we have learned earlier, which is chemical combination. You recall that in that particular lesson, we focus on ionic and covalent bonding. In today's class, we're going to further that conversation by looking at the coordinate covalent bonding. I hope you're ready. Let's go. So I urge you to write the topic and the date in your notes. Get your periodic table ready. Get a cup of water and let's have a fascinating learning experience. What are the learning objectives that we have set? At the end of this lesson, you should be able to understand and explain the concept of coordinate covalent bonding. You should be able to appreciate the role of coordinate covalent bonds in forming complex ions. And lastly, you should be able to apply the knowledge acquired, to identify and draw structures of molecules or ions. Let's look at the keywords that we need to be able to understand this topic better. We have dative, which is another name for coordinate covalent bond. Lone pair of electrons. This is usually when you have an atom having an unbonding two electrons that have not been used for bonding. Another name for lone pair is non-bonding electrons. Then you have complex ions. These are the type of ions that are usually formed by transition elements. Let's start with the icebreaker activity. I want you to figure out the next letter in this series. We have O, T, T, F, F, S, and S. Can you figure out what is the next letter? I'll give you 30 seconds and let's see how you would be able to unravel this mystery. You're welcome. So, what do you think that next letter is? Were you able to figure out the sequence? Okay. I want to tell you that this puzzle is actually a very simple puzzle. If I tell you what the answer is, I'm sure you will be laughing. Yes. The first letter there is O, and I want you to sing with me. O-N-E, 1, T-W-O, 2, T-H-R-E-E, 3, F-O-U-R, 4, F-I-V-E, 5, X-I-S, 6, X-E-V-E-N, 7. And what is the next letter? You're right. The next letter there is E, and that is 8. Well done. I believe that now you are prepared to actually learn what we have to offer today. Let's look at this inspirational quote. Excuse me. It was given by Vincent van Gogh. And it says, great things are done by a series of small things brought together. Never undermine the effort that you are putting in today, because this is what is going to transform you into that successful individual in life. So, That's our periodic table. Coordinate covalent, or what is referred to as dative bonding. What does it mean? It is a type of bonding, okay, where one atom donates both electrons to be shared with another one. I'll give you an instance. Suppose you and your friend walk down, okay, to the supermarket and you want to buy, let's say, a candy. If the candy is sold for 200 naira, if you ask your friend to pay the 100 naira share and your friend said he or she doesn't have money, if you decide to pay the 200 naira and still go ahead and share the candy with your friend, that's exactly what happens in coordinate covalent bonding. Only one out of the two participating atoms contributes the electron pair. This is different from what happens in ordinary covalent, where there is mutual sharing of electrons between the two atoms. And that's why in the name there is still covalent, but this is coordinate covalent. The condition for coordinate covalency or dative is the presence of at least a lone pair of electrons. You wouldn't have been able to bail your friend out if you are not buoyant. So for an atom to be able to supply the two electrons involved in forming the bond, it must have what we refer to as a lone pair of electrons. And you can see the image there of two friends who are on a date, and there's a competition about who wants to settle the bill. If one of them decides to settle the bill, okay, at the expense of the other one, that is simply showing coordinate covalent bonding, when one out of the two participating atoms contributes the two electrons that are involved in forming the bond. So what are some properties of dative bonds? 1, they often form complex ions in coordination compounds. 2, they exhibit unique bonding where one atom contributes both electrons. That's exactly what I said. Only one out of the two participating atoms contributes the electron. 3, it can result in stability for certain molecular structure. An example of a coordination compound is what you have here on the screen. And you can see that they are actually a complex, and that's why I refer to them as complex ion. You can see here, okay, cobalt, okay, linked to ammonia molecule. So the ammonia molecule are acting there as what we call ligands. Each of these represent ammonia molecule. And you can see how many are they? 1, 2, 3, 4, 5, and what? And 6. They are called ligands. Ligands are actually ions, molecules, or atoms that contain lone pair of electrons, okay? And they are able to claw to this central atom, which is cobalt. Usually the cobalt there is electron deficient, and the ligands are able to claw with their electrons into it. So this is a typical coordination compound, or what we call complex ion. All right, this also illustrates what happens there in dative bonding. The two electrons, okay, are donated or contributed by only one. This one is not contributing anything. But let's look at some examples. Consider the formation of ammonium ion. Okay, we are asked to illustrate the formation of ammonium ion and show that it actually undergoes coordinate covalent bonding. There are two stages. Stage 1 is going to be formation of ammonia. Formation of ammonia is the first stage of this process, and formation of ammonia takes place by covalent, ordinary covalent. Nitrogen is the central atom in ammonia, and it has 2 electrons, okay? It has 2 electrons. Let me indicate the electrons better. Okay, so nitrogen has atomic number 7, so there are 5 valence electrons around it. So that is 1, 2, 3, 4, and 5. And if you look at the formula of ammonia, it is usually between nitrogen and 3 atoms of hydrogen. So each of the hydrogen has 1 electrons, 1 electrons. And so there is going to be sharing of these electrons. Now, this is the condition that is necessary for dative there. That is what we refer to as what? A lone pair of electron. So, in stage 2, it is now that lone pair of electron which will now be used. This is the already formed ammonia molecule, and these are the lone pairs. Now, suppose the ammonia molecules want to bond with a hydrogen ion. A hydrogen ion has how many electrons? Very correct. It has 0 electrons because it has lost the only 1 electrons in it. So the hydrogen is electron deficient. So the ammonia is now combining with that hydrogen ion. So in order to differentiate the new bond that is formed from the ordinary covalent, we use an arrow. Okay, so this bond is a dative bond, and you can see the charge on the hydrogen is transferred onto the ion that is formed, and that is how an ammonium ion is formed. Isn't that interesting? I have a task for you to try and replicate what I've just done there. I'm giving you about 2 minutes to use the steps that I've used now and show me how hydrozonium ion is formed.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. So, how did it go with the exercise? I hope the tip I gave you was useful and you are able to solve the answer. But let's look at it together. So, the stage 1 is going to be what? Formation of water. You cannot jump to hydrozonium ion. There is an intermediate, and that is what? Water. Formation of water is the intermediate, and that is by covalent bond. So water is made up of oxygen being the central element, okay, and it has 6 valence electrons. So it's combining with 2 atoms of hydrogen, each of which have what? 1 electron. So these are covalent bond. This is a lone pair. This is another lone pair. So this is water molecule formed in stage 1. Now, in stage 2, because of the lone pair, the water molecule can then decide, okay, to bond with a hydrogen ion. So you can see that the hydrogen ion is electron deficient. So these 2 electrons are being contributed by the water molecule. So what is formed there is an hydrozonium ion. Don't forget that while these other bonds are covalent, this particular one is dative, and that's why we're using the arrow to identify it. So the charge is transferred there, and that's what you have as H3O plus hydrozonium ion. Were you able to arrive at this point? Well done for the effort at least. I now believe that you are able to understand coordinate covalent bonding better. Let's look at the practice question very quickly. A coordinate covalent bond could be formed between which of these pair of compounds? Is it A, ammonia and PCl3, B, BCl3 and AlCl3, BCl3 and ammonia, hydrogen ion, and AlC3+. The correct answer to this is actually between BCl3 and ammonia. And the reason is not far-fetched. It is because the boron here only has 6 electrons. That's what you have in BCl3. So there are only 6 electrons surrounding the boron. So the boron is electron deficient. And so it's going to be combining with the ammonia. And we have already said that the ammonia has a lone pair of what? Of electrons. So the ammonia will be acting as a ligand, supplying the lone pair of electrons, and it can bond with that boron. So the type of bond that is formed there is dative bond. Let's look at the next one. Fill in the blanks. A coordinate covalent bond is formed by dash of electrons. What do you think? What do you think the answer is? It's formed by dash of electrons. Okay? It's formed by singly shared electron. Okay? It's formed by, let's put it as electrons contributed by only one atom. Only one atom. Or you can find another phrase, okay, that can flow with that. It's formed by only one atom that contributes the electron. The next one lists 2 factors which will favor the formation of each of the following compounds. The first one is covalent bonds. The factors that favor covalent bonds include high electronegativity, high ionization energy, not electronegativity. Those are periodic trends. High ionization energy, yes, that is one. The second one is high electron affinity. High electron affinity. Okay, you can also have close electronegativity values of the atoms. Closeness of the electronegativity values. Any of these would be marked correctly. How about dative bond? You need an empty, okay, an empty orbital of an atom. An empty orbital of an atom. So one of the atoms must have empty orbital. 2, it must also have a lone pair of electrons. Don't forget we said that is the condition for dative. So these are standardized questions, and I believe that now you are better empowered to be able to answer them in the exam. So thank you for staying tuned to the end, and I hope that today's lesson has been very useful in your journey to achieving success in your chemistry career.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Don't forget to leave your feedback, suggestion, comment using the link displayed on the screen. Until next time when I see you in class, keep learning and keep growing. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.